Hello friends, very good afternoon. Myself, Dr. M.H. Annaya, and in today's video, we are going to study the development of the lateral surface of a square pyramid having base 30 mm and height 60 mm, which is cut by a section plane which is inclined to VP, inclined to HP and normal to VP, bisecting the axis of the solid. So friends, here the solid is resting with two of its base edges equally inclined to VP. So let us draw the top and front views of the pyramid for the given condition. So I just start with marking XY, the line of intersection of VP and HP, indicating first angle projection. And here I am going to mark a square of side 30 mm and join the diagonals here, and this will give you the top view of the square pyramid, and this is 30 millimeter. Each side of the pyramid measures 30 mm. We will name this as ABCD, A, B, C, D, the four corners, and we will project lines from all these, from A, from D, from C and all this, and obtain the corresponding front view to the given height of 60 mm. So I take a height of 60 millimeter along this O and then mark this as 60 mm, the height of the given pyramid, and join this O dash, the front view of the vertex, to all the corners. So this I am going to join to A dash, this is B dash, D dash, I'll say B dash, D dash, and this is C dash. So this is the base, and base is to be connected to the vertex. So I will just join O to A, O to C, O to B, and O to D. This is how the pyramid looks in the front view. And remember, the axis O dash, O1 dash is normal to HP, and that is covered by OBE. So I have shown all the three slant edges, four slant edges by visible lines. Friends, we have placed the object with two of the base edges equally inclined to VP. That is, all these angles are 45 degrees. This is also 45 degree. We have got the front and top views. O and O1 represent the top view of the axis. And here, friends, let us draw the development of the lateral surface of this pyramid, assuming it is not cut by any section plane. So friends, very obviously, we are going to get four triangles. Here, we are going to get four triangles, each measuring 30, 30. So 30, 30, 30, 30. And here I will join all these by thin lines to start with. This represents the edges of the base, and each of this length is 30 mm. This is 30, this is 30, and this is also 30, and this is O, the vertex. So this would have been the development if the pyramid were not cut by any section plane. Now friends, it is cut by a section plane which is normal to VP, means perpendicular to VP, and inclined at 70 degrees to HP, bisecting the axis. That means, since the section plane is normal to VP, it is seen as a line in the front view, and that section plane has to pass through the midpoint of the axis and at a height of 30 millimeters. So I will call this as SS. SS is the section plane which is inclined at an angle of 70 degrees to HP, 70. It is given here. Bisecting the axis means this is the midpoint. So we can call this as 30 here, half of 60, 30 millimeter height. You have the section plane passing like this. Friends, he says draw the development of the lateral surface of the pyramid. So here we have got, after this is cut the solid into two pieces, we have got two pieces here. One is this part, second is this part. Assuming we are trying the development for this P. So I will show that part P, the retained for the purpose of development by a dark line. So this portion of the solid is retained. So this is how this much portion only to be shown for the purpose of development. Friends, if you see the front view, the section plane is passing through the midpoint and it is cutting the slant edge OC, slant edges OB and OD, and also this slant. It's not cutting the slant edge, it is cutting the base. So obviously there will be 2 points for the base, one on AD, so this is AD, and one on AB. There will be 2 points. Remember, all these are true measurements, actual measurements. And friends, here is cutting OB and OD at this point, and O dash C dash is cut here. So 2 points here, 2 points here, 1 point. So totally there will be 5 points. Now friends, let us see from which edge the development has to be started. So here if you observe the front view, the slant edge O dash A dash is removed. So as per the rule, we have to commence the development only from O dash A dash, that is OA. So I will mark this as A, this is B, this is C, this is D, again A, because when you fold them together, OA and OA should come together. Friends, here this OD is removed, OA is removed, and here let us see how to get these points now. This slant edge O dash C dash is cut here. O dash C dash is the true length. This is the true length I will mark. This is also true length here. Because in the top view, this is the OC is parallel to VP. So O dash C dash will represent the true length. So this is the true length. All these slant edges are true lengths only, same length. TL I have marked here. I have shown a little bigger so as to show the points very clearly. Friends, since this is a true length, it is cut by the section plane here. So take this measurement O dash to this point and mark on OC. This measurement on OC. Suppose this is the point I am going to get. So this is over. Next comes friends, it is cut at OB and OD. OB and OD are cut here. But OB and OD are not the true length. So that has to be passed on or moved on to the slant edge which has got true length. And on this OB and OD, here I am going to take this measurement on OB and OD down. So say this is OB and this point is OD. So I have completed these two. Then comes friend the base. Base A dash, B dash, D dash, C dash is cut here, cut at this point. So I am just drawing a vertical line to get where exactly it is cutting AD and AB. So AD is cut here. Take this measurement on AD and near to A, on AD near to A. So this is 1 point. That measurement is this much. Similarly, on AB we have the same measurement near to A. On AB we have the same measurement. Friends, you got all the points. 1 on the slant edge here, 2 on the slant edges, 3, 2 on the bases. Totally you got 5 points. So we'll join all these by straight line. So friends, I will join these two by straight line. This is by straight line, and this is by straight line. And here friends, what is the portion to be shown by dark line? Let's see. OA is removed, so this does not exist. So when this is not there, you don't get this point. Then on OB and OD up to here, we don't have the part that is removed. This is not there, This is not there. On OC also, you don't have that part to be removed. And finally on OA, it's totally removed and you will not have this connecting line also. And here in this figure, the portion below the section plane, that is from this point to C, is visible, is retained. So I have to show by a dark line. Similarly here also, yes. So friends, here this is correct, and this line is to be retained. That is on OD, this is removed. On OB, this much is removed, remaining to be shown. And friends, you can see here, this part is retained. That is to say, this part, this BC is completely retained. B to C is there, and C to D is also there, and this part is also remaining. So this in cross mark indicates that they are being removed. So friends, here if you are naming these as 1, 2, 3, 4, this is 1, 0.2, 0.3, 0.4, and this is 0.5 because these are the separate edges. So we have got on OC 0.3. This point is 3. And the base edges 1, 5. So 1 on AD, it is 5. 5 and 1. So you get a point here, these two. And the remaining 2 and 4 are here. 2, 4 is this point, 2, 4. Friends, the portion of this, that is 1, 2, 3, 4, 5, and these base edges will indicate the development of P, the development of the lateral surface of the part P shown in the front view. Friends, I hope the presentation was interesting, and if you like this presentation and the video, please share this information with all your friends. Have a wonderful day, and I thank you very much for watching my YouTube video.